Hello students, in this video we're going to be looking at circle equations and how they are related to the graphs of circles. This is the 10th unit, the first lesson, and we're going to be talking about how to graph circles, how to identify aspects of circles from graphs, and how to encode that into equations. We're going to be talking much more about equations in the second lesson, but for today, much of what we're going to be doing is analyzing the actual picture, the actual graph. The learning target for today is discovering the relationship between the graph of a circle. That's the most important aspect that we're going to be looking at today. The equation of a circle, which we'll touch on as well, and its characteristics. And you'll find that a circle on a coordinate plane really only has two characteristics that we need. If we know those two characteristics, we'll be able to graph the circle. Just like with a straight line, right? You need the slope and the y-intercept. For a circle, you need two other pieces of information. As you can see down here, the two characteristics are radius and center. As long as I tell you where to start the circle and how big the circle is, you'll be able to draw it. So for each of these graphs, you're going to be stating the coordinates of the center and the radius of the circle. It should take you a couple of minutes here. Go ahead and pause the video and try this out, and then come back to see if you got it right. Okay, for each of these individual pictures, you should be able to identify the radius by just counting the distance from the center of the circle to the outside. You're either going to be going straight vertically or straight horizontally to find that radius. So from here, 1, 2, 3 units over, right? That's going to be 3 units. Same thing here, there's 2 units over. Here, there's 1 unit over. Here, there's another 3 units over. So that would make this circle and this circle congruent to each other. Why do we say congruent? Because the radius is exactly the same, and that's the only measurement we have for a radius. The centers are slightly different for each of these circles. This center is at 0, 0, which we also note as the origin. This center is at 1, -3. This center is at -3, 1. Important to know the distinction between the x and the y, and also the negatives and the positives. And also this center is at 4, 3, x, y. Okay, great. So now, once we're able to determine the characteristics, as we said in the learning target, once we can find the characteristics of a circle, we can take those characteristics and describe the circle to anyone else with them. And we can also encode them into an equation. All right. Speaking of the equation, before I reveal too much to you, each of the circle graphs above has its own equation. You can see these 4 equations, and these 4 equations correspond to these 4 circles. So there should be some way for you to figure out how to get from this to one of these, how to get from this to one of these. There's some kind of connection there. Look at the numbers, try to figure out the connection, pause the video, try this one out, and then come back to see if you got it right. All right, when I was reviewing this, I saw that the first thing that I noticed was that these last numbers in the equation, the 4, the 1, the 9, and the 9, well, 9 and 9 are the same. So that means 2 of the circles have the same something. And then 1 and 4 are different. And I also noticed that these are all perfect squares. As a matter of fact, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So all of these are a perfect square number. And when you look at it like that, you can see that all of these numbers indicate the radiuses of these circles. So for example, 1 squared, that's going to match up with the circle here, which is the radius of 1 unit. 2 squared, that's, 2 squared is 4, and 2 is the radius of this circle. So now the only thing that we're not sure about is which of these 3 squareds indicate this circle, and which of these 3 squareds represent this circle. So you can see that the radius value matches up with this last value. Radius value matches up with this last value. Now let's take a look at the other values. I have 1 and -3, and this equation, which we pulled from over here, happens to have a -1 and a +3. Oh, interesting. And then same thing here. I have a -3 and a +1. This happens to be a +3 and a -1. Interesting. What we should extrapolate or extend from that is that we're taking these values, the -3 and the 1, and we're, that's right, changing their sign to put them inside the parentheses. So the +1 becomes a -1, the -3 becomes a +3. So we should be able to take these other circles and use the center to try to determine what the equation should look like. Let's try to write out the equation for this one. Now we already know that the radius is 3 units, so that should match up with this 3 squared. I know that the center here was -3, 1 and became +3, -1. So if this center is +4, +3, we should probably turn this into a -4 for the x value and a -3 for the y value. So it should look like this. So that's what we think it should be, and as a matter of fact, this equation matches up perfectly with this equation. X minus 4 squared plus y minus 3 squared is equal to 9, which is 3 squared. So this one matches up perfectly. So the last equation left is this one, so that goes over here. Let's see how this connects to what's going on here. Okay, as per usual, we see that 3 and this 3 is going to match up. And based on this 0, 0 here, we put x plus 0 because this value should be corresponding to this value. And then we also put y plus 0. I could put minus here, it doesn't matter because if you add or subtract 0, it doesn't affect the value or anything like that. But if we simplify this, x plus 0 is just x. And then y plus 0 is just y. So you should see the relationship. We'll really focus on this next video, but you should start seeing the relationship between the numbers that are inside the parentheses for the circle equation and the values in the center. You should also see the relationship between that radius and that last value in the equation. So just for right now, this is how you set up the equation. Take the characteristics, the radius and the center, and then encode them into the equations. And here are some notes on circle equations. A circle with the center at origin, 0, 0, x squared plus y squared equals r squared. The center is whatever, and the radius is r. If the circle has a center at any other point, this point is h comma k, they're just variables, right? H comma k could stand for any numbers, right? In this case, the h and the k were 0 and 0, right? In this case, h is 1, k is -3. In this case, h is -3, k is 1. In this case, h is 4, k is 3. Right? So all we're doing is taking the value of h and turning it into its opposite, and then taking the value of k and turning it into its opposite, right? And we're still doing r squared, whatever the radius happens to be. So for this model problem, it says in the diagram, right, what is the equation for the circle? Well, here's my circle, and I notice that the center is down here. The center is at point 1, -2. Not too bad to figure that out. And then the second part is also not that bad to figure out. I'm looking for the radius, which means I'm looking for the center to any point on the circle. I've moved 2 units, so I can say that the radius is 2. So now what I'm going to do is I'm going to write out the general form of the equation, and I'm going to substitute in the values that I know. I know the center is at point hk, and the radius is at point r. So I'm going to label h and k, and I'm going to label r. Now I'm going to bring this equation down and try to start substituting in. The first and easiest part is to take this r value, which is 2, and substitute it in for the radius. So it looks like this. And then I'm going to take the h value and the k value and substitute them in for h and k, keeping in mind that there has to be a negative sign here and a negative sign here, regardless of what's going on here. So it looks like this. So since h is 1, I substitute in 1. Since k is -2, I substitute in -2. Now I'm going to simplify. I have x minus 1 in these parentheses. I don't need the extra parentheses. And I also have y minus -2. That's going to turn into y plus 2. And the last bit of simplification is to take this 2 squared and make it into 4. So there we have it. The equation for this circle is x minus 1 squared plus y plus 2 squared is equal to 4. Not too bad. Moving on to the next page here, the check for understanding is what you're going to be doing in class. You're going to be finding the equations of these 2 circles. One of them is extremely small and one of them is, well, you decide. All right, moving on to graphing a circle. So if I were to give you the equation of a circle, or if I were to give you the characteristics, it's very similar. The first step is to identify the center and the radius. In other words, where are we starting from? That's the center. And how far are we going? That's the radius. Then plot the center, hk. That's where we start from. Then use the radius to plot the edges of the circle. You can see there are 4 edges here. I don't want you to go too crazy finding the diagonal edges because that's a little bit less accurate and precise. I'm just asking you to use the radius, which in this case is 5, and count upwards 1, 2, 3, 4, 5, to the right and left 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, 5. And then once we use that radius to plot the edges of the circle, we just round out the circle. You're going to be sketching this. You don't have to use like a compass or anything like that. You're just going to be sketching it, with your pencil or something like that. So it doesn't have to be too crazily accurate. It just has to be curved like a circle. Let's try this one out. It says to graph the circle whose equation is x plus 2 squared plus y minus 2 squared equals 9. Well, we need two pieces of information from this equation. We need the center and the radius. Now we know in a circle equation, the center is going to be at h comma k. And we know that the radius is going to be symbolized as r. Looking at the general form of the equation, let's look at the center first. I know that in this case, minus h is positive 2. Since I'm looking at a minus h, that means our h value is going to be the opposite of whatever number's here. So this is a positive 2. That means our h, the first value of the center, is going to be negative 2. So this becomes negative 2. In order to find the k value, we look at this value and it says y minus 2. Well, y minus k, turns out that k is 2, right? Y minus, same, 2, 2. So the k value is going to be 2. Another way to think about it, this is a negative 2. The k is opposite, so that would be a positive 2. So that's my center. Let's plot this center now. Should be fairly straightforward to plot. It's at negative 2, comma 2. Boom. Next is to find the radius. This says r squared, and this says 9, so we can set up a very simple equation to solve for that. Well, if r squared is equal to 9, then we need to solve for r, which means we need to square root both sides. That means that the radius is equal to 3. So that means we're going to go 3 up, 1, 2, 3, from the center, right? We're starting from negative 2, comma 2. So we go 3 up, and mark an edge, 3 over, mark an edge, 3 down, mark an edge, and then 3 to the other side, mark an edge. So I'm just going to sketch this out. It's going to be very rough. I'm going to sketch out what it looks like just using my computer drawing tool. And there you go. Not exactly perfect, but what can you do? Just kidding. I sketched it out using my computer. I have a circle drawing tool that I can use. However, on your paper, you're just gonna draw a circle as best you can. Now let's label it because, of course, when you graph something, you have to label it. The label is the equation. And now I'm done. That's how you graph a circle. In the check for understanding, you're going to be doing that twice. You're going to be doing it once when I give you the equation. And the equation is easily decoded. And once when you are given the radius in the center, which is maybe a little bit more straightforward, fewer steps. All right, in the summary, try to pause this video and fill in the blanks for the summary. It should be fairly straightforward, but if you don't remember, go back and watch the video one more time, and you should be able to fill these out right away. All right, for the first sentence, the important characteristics of a circle's graph are the center and the radius. If you know the center and you know the radius of a circle, you can draw it. End of story. For that next sentence, it says we can write an equation for a circle that contains these characteristics. Remember, the equation is going to have all of the important information within it. The next part asks you to remember the equation of a circle. This is something you definitely have to know. You have to have in your notes somewhere. X minus h squared plus y minus k squared equals r squared. This is the equation of the circle. And it asks you what is the what and what is the what. Here we go. Well, we know that r is the radius and h comma k is the center. The rest of this document is just problem set, which you're going to be doing in class, so that means it's the end of the video. This was the video from Unit 10, Lesson 1. We focused on circle equations, specifically as it pertains to graphs. All right, folks, good luck studying.